Okay, 2 pages. Let's go. Let's go. 0.108 psi, 62.4 divided by 576. As the base gets larger, the pressure it exerts in the downward direction gets lower. Have you ever seen someone walking across the snow wearing snowshoes? The purpose of the snowshoes is to increase the size of the base to lower the pressure pushing down. This reduces the chance of sinking into the snow. 1.12 Atmospheric pressure. The sensation of being underwater and feeling the pressure of the water is familiar to many people. The Earth's atmosphere is like an ocean of air that has weight and exerts pressure. The Earth's surface can be thought of as being at the bottom of this ocean of air. Different locations are at different depths. For instance, there are sea level locations such as Miami, Florida, or mountainous locations such as Denver, Colorado. The atmospheric pressures at these two locations are different. For now, we will assume that we live at the bottom of this ocean of air. The atmosphere that we live in has weight just as water does, but not as much. Actually, Earth's atmosphere exerts a weight or pressure of 14.696 psi at sea level. This is known as a standard condition. Atmospheric pressure can be measured with an instrument called a barometer, which is a glass tube about 36 inches long that is closed on one end and filled with mercury. It is then inserted open side down into a puddle of mercury and held upright. The mercury will try to run down into the puddle, but it will not all run out. This is because of the atmosphere is pushing down on the puddle, and a vacuum is formed in the top of the tube. At sea level, the mercury in the tube will fall to 29.92 inches when the surrounding atmospheric temperature is 70 degrees Fahrenheit. Figure 1.19, mercury Hg barometer. There's just an illustration of everything we just read. Figure 1.19 is a standard that is used for comparison in engineering and scientific work. If the barometer is located at a higher elevation, such as on a mountain, the mercury column will start to slide. It will fall about 1 inch per 1,000 feet of altitude. When the barometer is at standard conditions and the mercury drops, the weather forecaster will talk about low pressure system. This means the weather is going to change. Listening closely to weather reports will make these terms more meaningful. A low-pressure weather system is often associated with cloudy, rainy, or snowy conditions, while a high-pressure system is associated with drier weather. If the barometer is placed inside a closed jar and the air in the jar is removed, the mercury column will fall to the level of the puddle at the bottom. Figure 1.20. When the atmosphere is allowed back into the jar, the mercury again rises because a vacuum exists above the mercury column in the tube. Figure 1.20. When the mercury barometer is placed in a closed glass jar, known as a bell jar, and the atmosphere is removed from the jar, the column of mercury drops to the level of the puddle in the dish. The mercury in the column has weight and counteracts the atmospheric pressure of 14.696 psi at standard conditions. A pressure of 14.696 psi then is equal to the weight of a column of mercury, Hg, 29.92 inches high. The expression inches of mercury thus becomes an expression of pressure that can be converted to pounds per square inch. The conversion factor is 1 psi equals 2.036 inches Hg, brackets, times 29.92 divided by 14.696, close brackets. 2.036 is often rounded off to 2. 30 inches Hg divided by 15 psi. 1.13 Pressure gauges. Measuring pressures in a closed system requires a different method. The board-on tube in figure 1.21, this is it, board-on tube illustration. Figure 1.21, the board-on tube is linked to a needle and can measure pressures above and below atmospheric pressure. A common tool used in the refrigeration industry to take readings in the field or shop is a combination of a low-pressure gauge called the low-side gauge and a high-pressure gauge called the high-side gauge. Figure 1.22, the gauge on the left reads pressures above and below atmospheric pressure and is called a compound gauge. This is figure 1.22. The gauge on the left, compound gauge, reads pressures above and below atmospheric pressure. The gauge on the right is called a high pressure side, high side gauge, which will read up to 500 psi. The gauge on the left reads pressures above and below atmospheric pressure and is called a compound gauge. The gauge on the right will read up to 500 psi and is called a high pressure, high side gauge. Safety precaution. Working with temperatures that are above or below body temperature can cause skin and flesh damage. Proper protection, such as gloves and safety glasses, must be used. Pressures that are above or below the atmosphere's pressure can cause bodily injury. A vacuum can cause a blood blister on the skin. Pressure above atmospheric can pierce the skin or inflict damage when blowing air lifts small objects like filings. These gauges read 0 psi when open to the atmosphere. If they do not, then they should be calibrated to 0 psi. The gauges are designed to read psig, pounds per square inch. Pounds per square inch gauge pressure. Atmospheric pressure is used as the starting or reference point. If you want to know what the absolute pressure is, you must add the atmospheric pressure to the gauge pressure, to the gauge reading. The following formula can be used. PSIA equals PSIG plus 14.7. This formula can be used as long as the gauge pressure is greater than or equal to 0 PSIG. For example, to convert a gauge reading of 50 PSIG to absolute pressure, you must add the atmospheric pressure of 14.696 PSI to the gauge reading. Let us round off 14.696 to 15 for this example. Then 50 PSIG plus 15 equals 65 PSIA, pounds per square inch absolute. Figure 1.23. New generation gauges are of the digital variety. Figure 1.24, okay. That's it. That's the last sentence. It just says if the, and then guess we'll figure out what the rest of it is tomorrow. Oh, wow. Can't believe that was only 8 minutes and 20 seconds. Felt like I was reading for an hour. Okay, there's 2 more pages. Oh, better figure out what pages those were. What pages was I just on? Okay, that was page 26 and 27.